Good morning. Today we are working on exponential functions. We're going to learn how to write equations from a table. We're going to talk about domain and range of exponentials and some key features. So one of the things that we know about exponential functions is that the parent function is a b to the x. A is your initial amount, it's your starting value. It is your y-intercept. And b is your common ratio. B cannot be equal to 1. If it has to be greater than 0. If it's greater than 1, it's an exponential growth. If it's between 0 and 1, then it's an exponential decay. So we have a table here, and one of the things we know about exponentials is they have a common ratio. Well, what is a ratio compared to a linear function that has a common difference? Well, for linear, we are adding or subtracting. For exponentials, we are basically, what are we multiplying by? So in order to see what we're multiplying, we're actually going to divide. Now, the first step is to make sure that the x's increase by the same amount. And they do in this case. This step is 1. So now we look at, I'm telling you it's exponential, so we're not adding or subtracting. We're trying to figure out what did we multiply by. So we're going to actually divide the second term by the first term. Then we'll divide this term divided by this term. Then we keep dividing to make sure that it has a common ratio. So we start with 2 over 2/3. 2 over 2/3 is 3. 6 divided by 2, I'll put times 3. We're going to multiply times 3. 18 divided by 6, that was times 3. So my common ratio here that they all have in common is 3. My starting value is my y-intercept. My y-intercept is where x equals to 0. So in this problem, where does x equal 0? The answer is 2. So my a value is 2. My common ratio is 3. So now my function is f of x equals a times b raised to the x power. My domain for this equation, so domain for exponentials is always all real numbers, unless it's a real world problem, which typically focuses in the first quadrant. Okay, my range is going to be that y is greater than 0. So y can be 0.1 or y can be 1,000, 2,000. So that range, though, is because it's part of my asymptote. My asymptote is y equals 0. Okay. So that means that this graph is never going to get to 0. Even if I keep dividing by 3, it's never going to get to 0. Okay. So let's try it again. Let's figure out what my common ratio here. Again, I look at my x's. They are increasing by 1. And now I'm seeing what is my second term divided by my first term. So I always divide by the one in front of it. I divide by the one in front of it. In this case, I am multiplying by 1/2. I'm multiplying times 1/2. Multiplying times 1/2. So what's being multiplied by, that is my common ratio. So this graph is actually a decay, because if b is between 0 and 1, the graph is going down. And as we look at our table, our graph is going down. Okay? We don't say 2. We don't say, oh, I'm dividing by 2, because if my b value was 2, then this would be an exponential growth. And it's not. The graph is going down. Okay? So what am I multiplying by? A is my starting value. Where is my y-intercept? My y-intercept is where x equals 0. So my y-intercept is 100. So my function of x is equal to a times b raised to the x value. My domain, this is not real world, so my domain is all real numbers. You might see it written like a double R, still stands for all real numbers. My range my range is going to be y is greater than 0. It's not equal to 0 because it's never going to get to 0 because it's an asymptote. No, even if I keep dividing by 2 or keep multiplying by 1/2, that 6.25 is now 3.125, and it just keeps getting smaller, but it's never, ever, ever going to get to 0, okay? Let's try it again. Are my x values increasing by 1? They are. What is my common ratio? So again, we take the second term, divide by the first term. Take the term, divide. Take the term, divide. That tells me what I was actually multiplying by. So times 4, times 4, times 4, okay? So if it's multiplying by 4 every single time, my b value is 4. Now a is where x equals 0. Well, guys, the graph doesn't have x equals 0. So I've got to work backwards here, okay? So if I put a 0 there, and I'll just go ahead and write it right there. I was multiplying by 4, so how do I get the number that was before 6? I divide by 4. So 6 divided by 4 gives me 1.5. So my y-intercept is 1.5. So remember, find where your x equaled to 0. That tells you the starting value. So my function is f of x equals a times b raised to the x power. Domain, all real numbers. Remember, if you just have an equation or you just have a table, my domain is going to be all real numbers. Again, the only time it's not all real numbers is if you're dealing with real world applications. My range on this is going to be that y is greater than 0. Again, it cannot be equal to 0 because it is an asymptote. Okay. Hopefully this video helped you how to write equations given a table. If it helped you at all, go ahead and give it a thumbs up, subscribe to this channel, and I will be posting more educational videos. Thanks, and have a great day.